let's get started with 5, 6. And so 5, 6 takes us into the complex number plane. We're going to talk about complex numbers here. So what we'll learn to identify and graph complex numbers, as well as what a complex number is. And then once we have that, we'll be able to add, subtract, and multiply those complex numbers. So vocab, the number I, imaginary number, complex numbers, and then the complex number plane, and the absolute value of a complex number. Alright, so skills check. We need to be able to do the Pythagorean theorem. We need to be able to square root squares, so I'll do one here. Let's see, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. So that's our answer for 1. Your job, 2, 3, 4, 5, and 6. Pause the video, try those problems, and press play when you're ready. Alright, so let's talk about complex numbers. So, we have our natural numbers, 1, 2, 3, right? And we can do real numbers and rational numbers. We got a half, irrational numbers, square root of 2. Remember, irrational, never going to stop. So 1.414, decimals go on forever. Now we're going to add in square roots of negatives. Alright, so up to now, if we did a square root of a negative, we say, whoa, can't do it, it's undefined, no solution, we're going to stop. But starting now, if we do a square root of a negative, we're going to be able to move on, because we're going to introduce the imaginary number I. And I is the square root of negative 1. Alright, I squared is negative 1, because if we squared both sides, the square root would go away, and we would just be left with a negative 1. Alright, so an imaginary number is any number that has a real number plus some imaginary number. So like 5 plus 6i, something like that. Alright, so again, the square root of negative a is I times the square root of a. We can get rid of the square root by putting an I out in front. Alright, so let's learn how to simplify this. The square root of negative 8. Can't do that unless we pull an I out front. And then we would have the square root of 8. Alright, and then we got to simplify from there. 8 is 4 times 2. So the square root of 4 is 2, and that gets to come out front. Right? The 4 comes out front as 2, and we're left with the 2 on the inside. So 2i root 2 is how we would write that. See if you can do the same thing for A, B, A, and C. Alright, so complex numbers. Complex numbers are any type of number that has a real number, like 5 or 10 or 15, any regular number, plus an imaginary part, so like 5i or 10i. Alright? And it's okay if either of these are 0. So 5 is a complex number, because that could be written as 5 plus 0i. And then 10i is also complex, because that could be written as 0 plus 10i. Alright, so let's simplify some of these. We've got the square root of negative 9 plus 6, and we want it real number first, then bi. So I'm going to change the order right away so we can get it in the proper order. And now we have to clean it up from here. So I see that I have a square root of a negative, so I'm going to take the I out front and make it positive 9. And then, can I take the square root of 9? Absolutely. I'll get 3i. And that's my simplified complex form, 6 plus 3i. Your turn. Root negative 18 plus 7. Rewrite it in the form a plus bi. Okay, so if we wanted to graph these, we could graph this. Now this is not our normal coordinate plane. This is the complex number plane, where all our imaginary numbers go up and down, and our real numbers go side to side. So if we had 3 minus 4i, we would go over 3, because 3 is positive and real. We would go down 4, because the i's are the up and down part, minus 4. And we would have this dot right here representing 3 minus 4i. So now with that, we want to find the absolute value. And the absolute value is the distance from the origin to the dot. So look at what we have here. We have a nice right triangle. We can use the Pythagorean theorem. And that's what it says here. Use the Pythagorean theorem, the square root of a squared plus b squared. This is why we did the skills check. So absolute value Let's do an example. I'm going to rewrite this as 0 plus 5i, right? So we have a real and an imaginary part. So we'll do the square root of 0 squared plus 5 squared, a squared, and b squared. And so that's the square root of 25. And so my absolute value of 5i is just 5. Let's do the one that we saw in the, on the chart there, on the graph, 3 minus 4i, square root 3 squared plus negative 4 squared. We've seen this before, 9 plus 16, square root of 25. Be careful here, a negative squared turns into a positive, so we get 5 here as well. Okay, absolute values of those are the same. See if you can do it for A, B, and C. All right, so additive inverse. Here's what we have for the additive inverse. Put this in your notes. The additive inverse of A plus BI is A minus BI. All right, so if we have negative 2 plus 5i, the additive inverse is negative 2. We're going to keep that exactly the same. 5i, we're going to keep exactly the same, but we're going to change the plus to a minus. So we have minus 2 minus 5i. All right, don't get tripped up and change the negative 2 to a positive 2. It's just the middle sign that changes. Negative 2 minus 5i. All right, so A, B, and C, give it a shot. All right, so now we can clean these up. Let's combine real numbers with real numbers and imaginaries with imaginaries. So we're combining like terms. 5 minus 2 is 3. 7i plus 6i is 13i. And that's it. That's all there is to it. We're just going to combine like terms, and we're done. 3 plus 13i. Your turn. Try those 3. All right, multiplying works the same way. Just remember that I times I is I squared, and that simplifies to negative 1. So let's see what happens here. 5 times negative 4, negative 20. I times I squared. Negative 20, I squared turns into negative 1. Okay, we know that from the definition of I. So now, what's negative 20 times negative 1? Positive 20 is our answer. Let's FOIL B here. FOIL F, negative 6. Outside, plus 10i. Inside, minus 9i. And last, plus 15i squared. So we have negative 6 plus I, combining these two, 10 minus 9, plus 15 times negative 1. Remember, I squared is negative 1. So this is really negative 6 plus I minus 15. We can combine these like terms. Negative 21 plus I is our answer. All right, so see if you can do some multiplying for 6, A, B, and C. All right, let's solve this. 4x squared plus 100. So from last chapter, we learned that if you don't have an x, we can just get x squared by itself. 4x squared equals negative 100. Let's divide by 4 and get x squared equal to negative 25. We're going to square root to get x by itself. And up till now, we would have stopped. But here we know we can do the square root of negative 25 if we use I. I on the outside, square root of 25. Square root of 25 is 5. So x equals 5i. And that's our answer. All right? Now on this, remember that when we do square roots, we can do plus or minus. So we're going to have plus or minus 5i, right? Because we should have 2 solutions here. And so we have a positive one and a negative 1. All right, so get answers for A, B, and C. All right, last example. So they give us this equation here, and they say, give me the first 3 output values, all right? So that means I'm going to put a 1 in for Z, a 2 in for Z, and a 3 in for Z, and just see what happens. So I've got 1 squared plus I, and that's equal to 1 plus I. All right, let's see what happens if I go f of 2. Now I'm going to get 2 squared plus I, which is 4 plus I. And lastly, what happens if I plug in 3 for z? I get 3 squared plus I, and I got 9 plus I. All right? So, just that simple. We can plug those in. And so you can do something similar here for 8. All right? Plug in 1, 2, and 3 for z and see what happens. Clean it up. That's it. Any questions? Ask me tomorrow in class.